For this problem, the statement reads, if you have a polyethylene sample with a percent crystallinity of 45.3% and an amorphous density of 6.796 grams per centimeters cubed and a crystalline density of 8.214 grams per centimeters cubed, determine the mass of the specimen if the polymer is in a 75 cubic centimeter container. So what we're going to be doing here is using the percent crystallinity equation. What polymers look like in a block, when they're used, is they're usually going to be squiggles, and then in the squiggles there's these random sections of crystallinity that look something like this, where they might line up, something like that. So the percentage of these crystalline regions here in comparison to the whole, and here's the amorphous in comparison of the whole, those are what the percentage crystallinity is representing in this case. So we know, just writing down what we know from the problem statement, the density of the crystalline area is going to be our 8.214 grams per centimeters cubed. The density of our amorphous region is going to be 6.796 grams per centimeters cubed as well. And then the density of our overall, we don't know. That's what we need to find in order to find the mass of the specimen, because we know that the size is 75 cubic centimeters. So the equation that we're going to use is the percent crystallinity equation, which is going to be percent crystallinity is equal to the density of the crystalline region. The row sub S here I'm using as solid. Some people use P sub T for total. Solid makes more sense to me, so that's what we're going to use in this example. A, and then we've got row sub S. All right, and that is our percent crystallinity equation. Again, this is going to be density crystalline, density of amorphous, and we have density of solid. So we can go ahead and use these values and plug in what we know. It gives us the percent crystallinity of the sample. So we have that as 45.3%, so 0.453. This is technically times 100 to get that percentage. Forgot to note that is going to be equal to 8.214 times S minus 6.796 over row sub S times 8.214 minus 6.796. There's our equation. We know everything except for one variable. And so we can go ahead and plug this into our calculator. We should get that the density of the total solid sample is going to be mass over volume. Volume, which is going to be equal 7.34-ish grams per centimeters cubed. All right, so since we know that our density is mass over volume and it gives us a volume that the size of the sample is, which is 75 cubic centimeters, we can go ahead and rearrange the equation so that we get our mass, which is what we're solving for, is equal to the density times the volume. And we can go ahead and just plug everything in. So we have 7.34 times 75 centimeters cubed. Our units, centimeters will cancel out because we have grams over cubic centimeters here, times cubic centimeters over 1. Those cancel, get us a value of 550.5 grams. And that is your final answer.